Hello guys, so in our last video we were able to add logs and what we gonna do today. So our main goal is to make an intent graph for a binary so that it can like show what the intent like a binary has. To make that intent graph we need to study a single binary, so we have to change the structure of our EDR so that it can also it can also scan a single binary as we want, rather like scanning the whole what do we say windows. It will be like mode based, like if we want to like scan the whole windows or we want to scan a specific file. For example, right now it's scanning the whole windows right now. As you can see, it's lighting up like a Christmas tree. And if I can change some codes here and just changing the mode to like single one, this is the EDR mode. I can change it to the single binary and then like stop the EDR, delete the EDR and rebuild again. Let's compile, start it again, like start. Now what it gonna do, it will gonna scan only single binary which we defined. So in our what we say in my code I defined only POC, this file. So if I run this, it will gonna scan this only. So you can say it's scanning only the single file, and when it closes it will gonna give us the information that is being closed. So if I open notepad right now, it won't show anything regarding the notepad. So that's the main goal for today, so that we can work on intent graph on specific file base, so that after making our intent graph so good so that it can run globally. So let's start with our code. And the main thing, first of all we should add our what we say modes here. So I will use enum so that we can like write what we are doing here. So let's start with type def and write it like EDR mode. And here we can just write global mode equal to 1, and another one is target mode. And we can write here 2, and we have to define, just write it here EDR mode. And now we have to create the what we say mode here. So the name is like EDR mode, and we have to give a variable. So let's call it mode. And right now we want to work on target mode. Just copy this and paste, and we are done. So we created a mode and we're going to use this. And why we are using this rather than hard coding things, because if like anyone reads the code, they will know what kind of things we are using rather than defining 1 and 2. So to scan a specific binary, the thing happens here. So whenever a process is created, this portion, this notify give us the what do you say alert that this process is being created. You can like create two things here. One thing is like you can create a gate here and specify I want to run this kind of binary, and it will gonna work similar as we shown in the video earlier. But I don't want to do that. I want to make it like a policy in a different function, so that it will gonna, so every time I want to change something, it won't I won't have to change the gate, I just change the policy. So let's start making a policy here. So I will just call it boolean should monitor process. And what we're gonna pass here, because we need a policy and we need for the parameter which give us the real-time callback. So for that we have to use this one. As you know earlier, that if I if I show this, these have bunch of stuffs, like when we like making our this function I talked it about a lot, so you can go and see the video. So basically we can make so many policies regarding that. So there is a command line policy, there's a creating thread, a parent thread. So rather than making a gate, so that's why I thought I should make a policy rather than making a gate. So because we can customize so many things about the binary. So right now we need this image file name. Whenever a process is created, it will gonna give us the image name, and we can correlate things with that. So that's why we have to pass it here in our policy function. Here is it. So I will start with in and copy this and paste it and just call it info. And things we have to check, if I go down there, where is notify. So same thing we have to check above, so that we don't make any mistakes. So let's check if what we say info is null and info image is null, and we can say info image buffer is null. So we just return false and we're gonna move on. So for the global thing, like if we want this function to be true, so we can just check like if mode is equal double equal to like global mode, then it will just return true and we're gonna run as a global. And what we like now we have to like create a policy. In policy that we want what we say a binary name, and that binary name we're gonna use here. To do that, there's two things right here. Okay, like in our last thing we have to compare the static versus dynamic DLLs, right? So here what we're gonna do, we're gonna compare with the target and versus the process like image path. So by doing this, we can get a correlation, and if it's become true, then we're gonna run the code. So right now, what we need a target. And another thing, like when we using like DLLs, like dynamic DLLs, we got to know that dynamic DLLs has like Unicode string. So right now, what we're gonna do, we're gonna make a Unicode string here and define it globally, and just call it target, and just call it image also. So we made a Unicode target image, and we have to define it like in driver entries. So for that we have to do TL initialized what do we say Unicode string. So that's what we need to initialize our Unicode. So it take a pointer, and that's it. So we gonna do, we just copy this and paste it here, and it's take a pointer, right? Target image. And another thing is take source, and source is our like poc.exe, that what we gonna check against our EDR. So we initialize things. We have our we say Unicode string with the target name, and now what we're gonna do, we have to extract the names from the image name. So you already know when image name comes. If I go here and let me like start this again to show you. So if I run, this is the image name, just like previously, how we extracted the DLL name from the dynamic DLLs. We're gonna do the same thing again, and we're gonna search for the backslash here. So let's start making a function here, a boolean, and we call it extract image name. And for that we need two things here. One thing is like image name, so that's what we're gonna do. We have to check what its data type, and it's like PC Unicode. So that's what we're gonna do here. uh, and just write it path here because it's easy. And another thing, we have to take output and where we're going to save it, so we have to define a Unicode here also. Unicode string, just call it name, and that's it. And that's what we're going to pass here. So it's a Unicode, so we don't have to uh, let's copy this. And one thing you have to notice, that it's a constant. We don't want a constant here, so we have to remove that and just write it name. So we added our parameter, unless we can start what do we say, our function for the extracting image name. And first of all, like we already doing this all the time, like checking things, so we can check that if path is empty and path what we say, buffer is empty, and we can check this path uh, path length equal to 0. Then we just gonna exit the function over by returning false. And now we can start our thing. So like if you remember, if I go here, here is it. So if I compare this, so what we did here last time, what we did here, we like saved the things, and after that we ran a loop and saved everything. So, but that thing we can't use like this function to initialize our Unicode string to handle, to give it to the kernel to handle, because there is a null terminator behind the what we say DLL. So here we are not sure in by like extracting the name, so we have to do it manually by assigning what we said the target name here. So and we have to also change some things here, because I want my code to be universal. So for that we can start our saving things, pwchr, let's call it buff, and we have to save path buffer. And again we have to make a length. So length, earlier we were using ulong, and now we will gonna use ushort, and we make sure that our ushort won't get negative. So let's call it length, and the same thing again, path and length, and it should be divided by the size of wchar. Now we have the length, and I have to create a variable ushort. I'm right now again I'm making a ushort, and you short let's call it I, like in our previous code. And now we're making a what we say loop. So here what we you gonna do, we're gonna use like length is equal to what do we say length, and we are not using a negative one. We are going to change this also, so that our code will become universal. But right now I'm just gonna give you the example what we're gonna do, and when I post this code to the GitHub, everything will be changed and perfect. So I gonna just make sure it won't be a negative, and we have to decrement I, and we have to check if like buff I minus 1. This time we are minusing here equal to what we say L backslash here. So that's it. If it's like we reach here, we're gonna what we do, we're gonna break it so that we can get the value of I, and after that we're gonna start our things. So what we're gonna do, like just I like told you the last time, we can't just use this like function because we know that in the what we say DLL names there is a null terminator, and right now we don't know there's a null terminator behind the what we say the binary name, so we have to add these things manually. So where we gonna like put things, so we have the what we say name here, so name, and we have to put like buffer, and we're gonna use the same thing here like we used it earlier. So we were gonna check that I if like not negative or not zero. Then what we're gonna take, we take a pointer, what we say above high. Oh wait a second, and if it's not happen, then we're gonna just use buff. So we added the buffer. Now we have to add length, and for the length we can do like this, like length minus I, and length minus I means you can say, for example, if like uh, for example it's a what we say a buffer, and for example I just take a just take a jack. So there is like five, like 1 2 3 4 5, and there's a backslash here, and we have to check another thing, a folder we fit right here. So if it comes like 1 2 3 4 5 6 7 8 9 10 11, so 1 2 3 4 5. So if we minus like length to I, we will gonna get the length. That's why what we are doing here, and we have to convert it to the bit, so we have to multiply with the size of wchar, and we have the length. Another thing in the Unicode, I like in my first video I told you that Unicode is a like structure, and there's another thing is like maximum length. So that's what we're gonna add here to make it complete Unicode maximum length, and we will gonna make it equal to the what we say the length. So and we are done. So it will gonna extract our what we say image name, and at last we have to return true. So now what we're gonna do, we're gonna extract the name, and we're gonna use the function extract, where is it, extract image name, and we're gonna write it here, and we're gonna go pass the parameter. First is like Unicode, and this is like image. It's already have the same data type, so we don't have to pointer this thing. We have to add pointer because we made a Unicode and is calling the pointer. So what we gonna use it name here, and we are done. So after getting the names, what we're gonna do, we're gonna compare things. So so we are comparing right now like Unicode strings only, so that's why we are using these functions. So let's copy this, and we're gonna say if this thing uh, and how you're gonna use it, string one, just write the name. It's a pointer, let me check. Yes, it's a pointer. And another thing is what we said, a target, so it's a target here. What's the target name? Target image. For the case sensitive, we can just add it true, and if it's equal to 0, then it will gonna return true, otherwise it will gonna return false. So we have done like the majority of the task, and we just gonna use this in our notify function and check if it's working, or I just make a blunder in our code. So here we can use it like this. If is false, and we have to add parameters here, and we're gonna add info, then it will gonna return and exit the function initially, so that the whole code will not work. So let's copy this and check if I'm making any mistake, and see there's one error, and the error is length, and it's fine now. Let's stop the EDR. And let's try to compile it. And it's done, and let's run it and check if it's working as we assume. So as you can see, it's working as we assumed. But the thing is, like right now, it's will gonna show all the closing, like the process is being exited. So we have to change that also. So here we can check like which like if we here we are registering the PS, right? So we can just move it to above so that after registered the thing will work. So after adding the PID in the PS slot, it will gonna run the command, and we're gonna check that find PID. Let me check find PID is the right function, right? Free memory find PID, yes. Find PID, and we have to write process ID here, and we can say like if PS is null, it will gonna return. So let's check if we gonna what if we gonna like what we say save solve the exit problem. The same problem will be coming from the length. Let's stop the EDR and let's compile it and check if it's working or not. Start norm, open debug view, run as administrator. So as you know, it like what we say showing only one what we say uh, the exit process, and the thing is like norm 0 empty. This thing we're gonna fix it in later videos. So that's what we do today. What we like if I want to check like it's running like say global also, we can change here and like stop the EDR and compile it again and run it. Let's hope it's run like globally. If I write here, so as you can see, it's already running and taking all the what we say alerts. So what we did today, what we like we separated, we made it our no modes in our EDR, like if we whether we want to use the kernel level, sorry, but whether we want to use it globally or targeted base. So why we are doing this? Because we want to make an intent graph for like a binary, so that it will can show like why this binary is suspicious rather than like running globally. And after like making our what we say intent graph strong enough, which can differentiate between the windows like signals and the malicious signals, then we will gonna like run it together. And the idea is that like the real idea what it does, it will like runs first, it runs globally, and it's gonna after that, if it finds any process suspicious, it's gonna separate a target and then study the target separately. So that's why we need like two things here. So run it globally, and another thing is target like separately. And right now, what we're gonna do and what we're gonna like focus about in next video, we're gonna make the intent graph, and it will gonna take some time. Like uh, it's will gonna take time, like because it's like so complex, and I'm trying to understand things, and it's taking me like weeks. So I hope if you like the video, or if you like the video, please what do you say, give a share it and like it, and like comment if you want to ask me anything. That's it, I guess. Thank you guys for watching this video.